All right, 3.8, use inverse matrices to solve linear systems. So the identity matrix is an n by n, or let me say, n by n is a matrix with ones on the main diagonal I'll show you a picture of that in just a second, and zeros everywhere else. Denoted as, or denoted, let me say it's with I, and it'll be a capital I for the name of the matrix. So we have, if we had matrix A times matrix I, so the identity matrix, that would be equal to matrix A, and vice versa, because we know with multiplying in matrices, order does matter. The identity times matrix A is equal to matrix A. The identity would always be the same size as whatever the matrix that's being multiplied as. That's the whole point of it being an identity. And it has to be a square matrix, so it can't be like a 3 by 2. Like, it would have to be like a 2 by 2, 3 by 3, 4 by 4, something like that. So the identity matrix for a 2 by 2 would be 1, 0, 0, 1. So it's this first diagonal going down where the ones occur. If you had it for a 3 by 3, it'd be 1, 0, 0, 0, 1, 0, 0, 0, 1. And then we can also say that two matrices are inverses of each other if the product of each gives the n by n matrix, or the n by n identity matrix. So like just in normal math, we would say that 3 and 1 over 3 are inverses of each other, because when multiplied together, it gives you 1, or the identity. And so very similar to that, we have that for matrices. So if we have something like matrix A times matrix B, and it gives you the identity, you would know that those are inverses. And on the flip side, if you had B times A, it would also give you the identity if they're truly inverses of each other. I only require you to find the inverse of a 2 by 2 matrix by hand, which is what I'm about to show you. It is not impossible to do with a 3 by 3, but it would just take you a long time. So you can do the 3 by 3s on the calculator. So how do we find it? So the inverse of a 2 by 2 matrix So we'd say that the inverse of matrix A, and I'm just going to put letters in for it. And so the matrix is going to be A, B, C, D. So the inverse, we write it as A to the negative 1. Okay, so there's actually a little negative 1 button on your calculator. And so you would raise it to, well, actually, I think there's an inverse button on your calculator anyways. We'll look at that when we go to do the matrices. But, so that's how you would enter it into your calculator, is like that. But it's the same thing as 1 over the determinant of A times, it flips the main diagonal, so it's going to be D, and then A is going to be on the, so those two things flip, B and C stay where they are, but they become negative. Now, if they were negative to start with, they become positive. Okay, it changes the sign is really what we should say. So, negative B and negative C. So, it's 1 over the determinant of A. So, we would rewrite that as 1 over AD minus BC. Okay, so that was what you would have done in the last section. Well, the determinant times, and then we just copy down the matrix. So D, negative B, negative C, A. And this is assuming that AD minus BC is not equal to 0, because obviously we can't divide by 0 still. That still applies. So that's how we would do that. There's one other thing. In this section that when we get to the problems I'll show you, but it's how to solve the system of linear equations in 2 and 3 variables without having to do it by hand. So I need to do it by hand early on, but now I'm going to show you how you can do it easy.